Section 4.1, Congruent Figures. You can determine whether two figures are congruent by comparing their corresponding parts. Congruent polygons have congruent corresponding parts. So in the example here, you can see that each of the sides of one figure pairs up with a side of the other, as well as the angles. So as long as you can prove that, in this case, let's say B is congruent to F, A and E, D and H, and C and G, as well as all matching side pairs are congruent, you can prove the two polygons are congruent. When naming congruent polygons, you must list corresponding vertices in the same order. Therefore, since we know in this particular diagram that angle C here is congruent to angle R, and P and A are congruent, and then B and Q are congruent, when we go to name or write the congruent statement for this, we're going to list it so that way the corresponding pieces match up. So we'll say that triangle CAB is congruent to triangle RPQ. Notice how the letters line up in terms of their congruent counterpart. C and R are in the beginning, A and P are in the middle, B and Q are at the end. Triangle ABC is congruent to XYZ. Complete the congruent statements. So if segment AB is a part of ABC and it's congruent to something, it has to be congruent to XY. Remember, corresponding pieces in the names match up. A corresponds to X and B corresponds to Y. So if we look at 2, 3, 4, and 5, we're doing more of the same. So if ZY is congruent to, in this case, we would be looking at CB. Angle Z is congruent to angle C. Angle BAC is congruent to angle YXZ. And angle B is congruent to angle Y. We've managed to match up all of the corresponding parts they asked us for. And the easiest way to do that is when they give you one half of the statement, look at the name and see where the letters correspond to in the other figure, and then list it that way. If HIJK is congruent to LMNO, what are the congruent corresponding parts? So they gave us a diagram here, which is great. But because they gave me the congruent statement, I don't even need to look at the diagram. I can match those pieces up just off the name alone. So for sides, I know that HI is congruent to LM. I also know that IJ is congruent to MN. I know that JK is congruent to NO. And I also know that HK is congruent to LO. And I did all of that from using just the name or the congruent statement. I can also do the angles the same way by pairing up the letters based on their corresponding location in the congruent statement. So H is congruent to L, and angle I congruent to angle M. Angle J is congruent to angle N, and angle K congruent to angle O. If triangle WYS is congruent to MKV, what are the congruent corresponding parts? All right, so we can base this just off the name again. You could draw a diagram if you wanted to, but like I said before, the naming mechanics of the congruent statement are very, very helpful. So we know that WY congruent to MK. We also know that YS is congruent to KV. And we know that WS is congruent to MV. And in terms of the angles, well, we've got W is congruent to angle M. We know that angle Y is congruent to angle K, and we know that angle S is congruent to angle V. Here we're looking to find all the values of the variables. And so they're telling us the two triangles are congruent. So if that's the case, we should recognize that Z and angle D are both correspond to one another, meaning that they're congruent parts. So to find Y, we're merely going to take 2Y equals 30. We're going to set the two angles equal to each other, in which case we get Y to equal 15. To find X, we should recognize here that XY corresponds to, XY corresponds to FE, so we're going to set these two equal to each other. So we've got 9 equals 3x, and that means x must equal 3. In the second example, we have a very similar idea here. They tell us that triangle ABD is congruent to triangle CDB. Well, here we have angle ABD, so ABD, and here we have triangle CDB, or angle CDB. These two angles here correspond to each other in terms of the congruent statement and in the figures. So what this tells us is we're going to set these two measures equal to one another to solve for x. So we're going to take 5x equals 75, we'll divide by 5, and x in this case is going to equal 15. Suppose that triangle WYS is congruent to triangle MKV. If if angle W is 62 and angle Y is 35, what is the measure of angle V? So the easiest way to approach this is to think about what we know. Well, the angles W, Y, and S of a triangle should add up to be 180. Well, let's think about it. We've got the measure of angle W plus the measure of angle Y plus the measure of angle S equals 180. But in this case, they want to know the measure of angle V. Well, V corresponds to angle S. So instead of saying angle S here, we can merely replace this with angle V because they should be the same measure if they're congruent triangles. So all we're going to do is we're going to take 180 minus the two angles we know, and we're going to figure out what essentially is the measure of angle S, which is the same measure as angle V. So 180 minus 62 minus 35 gives us a total of 83 degrees, which is the measure of angle S, which is also the measure of angle V. So angle V is just 83 degrees. Congruent triangles have all 6 pairs of corresponding parts congruent. Theorem 4.1, the third angle theorem, states that if two angles of one triangle are congruent to two angles of another triangle, then their third angles must be congruent. Which makes sense. If you know that two of the angles of each set of triangles is equal, and all triangles add up to 180, then the missing pieces have to be the same as well. So in this case, if A is equal to D and B is equal to E, then C and F must be the same because they're both going to add up to be 180, and they already have two of the exact same measurements included. Here it asks, are the following triangles congruent and justify? Well, let's see. We've got two sets of angles, which means these third set of angles here, B and D, must be congruent. And that's your third angle theorem. All right, and then we have two sets of sides, but we actually have the third set of side as well. The two triangles share a common side. So in this case, we know that AC is congruent to AC by the reflexive property. So basically, we were able to show that all of the pieces we needed to show the triangle, all 6 pieces of the triangle are congruent. So therefore, yes, the triangles are congruent, and so we'll write our congruent statement. We'll say triangle ABC is congruent to triangle, oops, I forgot the triangle symbol, triangle CDA. Are the following triangles congruent? Justify. So here they're telling us SRT and PQR. They want to know if they're congruent. Well, right now I can tell you that these angles are congruent by VAT. These angles are perpendicular, which means they're both 90, so they're congruent. And therefore we can prove that these angles are congruent by the third angle theorem. But we don't know any of the sides, so we can't prove congruence then. In the next example, we've got a triangle ABC and triangle FGH. Well, we've got matching sides, we've got angles, except for one pair, but since these two match up, we know that we have A is congruent to F by the third angle theorem. Therefore, triangle ABC is congruent to triangle FGH. All right, so now we're going to prove triangles congruent using all 6 pieces. Later in the week, we'll start looking at how to do this quicker, but for right now, we're going to have to prove all 6 pieces are congruent in order to show, or all 6 pairs of corresponding parts are congruent in order to show congruence. All right, so they start off by telling us that AD and BE bisect each other, and AB and DE are congruent, and AD, or angle A and angle D are congruent as well. And that's your given statement. They provided that in the very beginning of the problem. Then they say AC and CD are equal, and BC and CE are congruent as well. Well, that goes back to the first statement. They tell us that the 2 lines bisect each other, which means they're creating congruent segments, because to bisect means to cut at the middle or create 2 equal halves. So this would just be definition of bisector. Then they talk about ACB and DCE. Well, ACB is this angle here. DCE is this angle here. And we know they're congruent by vertical angle theorem, or VAT. The last piece here they talk about is angle B is congruent to angle E. And we know this because of the third angle theorem. And then last but not least, they tell you that triangle ACB is congruent to triangle DCE. Well, we've proven all 6 pairs of corresponding parts are congruent, so our reasoning here is just definition of congruent triangles. In the next one, they've given us that LM and LO are congruent, MN and ON are congruent, and that angle M and angle O are congruent, and angle MLN is congruent to angle OLN. And they want us to prove that the 2 triangles LMN and LON are congruent. So given, I don't have enough space to write all this, so I'm just going to do this. We have this whole phrase here. Then the reflexive property, remember the reflexive property talks about something being congruent to itself. Well, chances are that's going to be Ln. So Ln is congruent to Ln. Step 3, they use given again. So what they must have done here, if we go back to the beginning, is they must have separated segments and angles. So for the first part, this would be the segments, and then the other half, we've got our angles. So that's 3. Then they talk about third angle theorem. Well, we already know that we've got congruent angles here, here, as well as here. So the third angle theorem must be telling us that M and L is congruent to O and L. So that's what we're going to say here. Angle M and L is congruent to angle O and L. And then once we've done that, we've now proven all 6 pairs of corresponding parts congruent for the triangle. So now we can finish our proof by saying triangle LMN is congruent to triangle LON.